Hello, 6th graders. Welcome to Big Ideas Math, Contract Math, Section 9.3, 2012 edition, Experimental Probability Lesson. Pause while you write Section 9.3, 2012 edition lesson in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is compute the experimental probability of an event. Copy the following key term, definition, and example exactly as it appears into your notebook. Experimental probability is the probability that is based on repeated trials of an experiment. So the probability of an event equals the number of times the event occurs divided by the number of trials. Today we'll be beginning on page 400 in your textbook. The example 1 is standardized test practice. 13 out of 20 emails in your inbox are junk emails. What is the experimental probability that your next email is junk? So, in order to figure that out, the probability of that event is the number of times the event occurs divided by the total number of trials. So we have 13 emails that are junk divided by the total number of emails we have. So 13 out of 20 is the probability of having junk emails. So the probability is 13 out of 20 expressed as a decimal. That's 0.65. As a percent, that's 65%. So the correct answer is D, 65%. Example 2, we're going to be making a prediction. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? Find the experimental probability of a rainy day. So we need to remember that the probability of the event that we're interested in happening equals the number of times the event occurs divided by the total number of trials. So the probability of rain equals 2, because it rained 2 days, over 12, because there were a total of 12 days that we looked at. So 2 out of 12 equals 1/6. So to make a prediction, we're going to multiply that probability of rainy days by the number of days in April. And there are 30 days in April. So 1/6 of 30 equals 5. So we can predict that there will be 5 rainy days in April. Moving on to page 401, example 3, comparing experimental and theoretical probabilities. So the bar graph on the left shows the results of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? How does this compare with the theoretical probability of rolling an odd number? So find the experimental probability of rolling a 1, 3, or 5. So the bar graph shows 10 ones, 8 threes, and 8 fives. So an odd number was rolled 10 plus 8 plus 8, which is 26 times in a total of 50 rolls. So the experimental probability of that event was 26 over 50. So the probability of odd was 26 out of 50. So that was an odd number was rolled 26 times out of 50 times. So that reduces to 13 out of 25. And let's look at the theoretical probability. The probability of rolling odd was 3 out of 6. There are 3 odd numbers, and there are a total of 6 numbers, which is 1/2. So the experimental probability is 13/25, which as a decimal is 0.52, as a percent is 52%. So the theoretical probability is 1/2, 50%. The experimental and theoretical probabilities are similar. They're not exactly the same, but they're similar. So our experimental probability was slightly higher. We got just about 2/100ths higher with our experimental probability than we did with our theoretical probability. Your assignment for this lesson is to complete the On Your Own problems 1 through 3 below. They are also on page 401 in your textbook. Show your work and be prepared to share during our next class. Please remember, to earn credit for viewing this flipped lesson, you must complete your exit slip, come to our next class prepared with the journal pages or other work from the flipped lesson completed, and be prepared with any work that was assigned in the flipped lesson completed. Be prepared with any questions you have for the teacher, and always have a good attitude. We'll see you next time in class.